Hello everyone and welcome to class. So, so far we discussed ER modeling, functional dependencies, normalization, and then we also had a brief introduction to SQL last session. So today I'm going to continue on um, finishing the DDL, doing ideally some hands-on in class, um, and that's it. Before that, just a reminder that this Thursday you have your midterm exam, so October 9th, I think, the regular time of our class. And I received a few emails about the format of the midterm. So your midterm includes some multiple choice questions, true false questions, more specifically 10 multiple choice questions, 10 true false questions. And then you have two problem solving questions. In terms of weight of each, so each multiple choice questions has 1 point. Each true false question has 1 point. So in total, for multiple choice questions, you have 10 points, true false, 10 points. And then problem solving question 1, which is your ER modeling. I give you a case, for example, similar to assignment 1, but I provide more hints for you to understand what are your main entities. So it's not that like how to say open for you to guess or think about entities. So I provide it has more clear structure because you have limited time, and then you have to draw the ER model. So the things that you have to know is that how to when you are, for example, in paper-based exam and you're not having access to ERD plus or other tools, how do you want to show, for example, entities or different types of entities, right? For example, this is regular, this is associative, this is weak entity, right? Or for example, for the attributes, this is multi-valued, this is derived attribute, and then this is composite attribute, right? So these are the things that you have to know. Or if you have an entity like subtype, supertype, again, you have to know how to show that. Like if this is, for example, disjoint, or for example, if they are disjoint using DCS. And so these are the basic things. And then for each entity, please do not forget to show the unique identifiers, primary keys, at least a few attributes, and what else? If you have many-to-many relationships, try to use associative entities. And then you have a normalization and dependency question. So your problem-solving question 2 is actually normalization. So I think I'm not sure, but I think this one had 20. This one 10 points, something like that. Around this, maybe 2 points up and down, but your total score is 50, which will be converted to the score from 100, right? And for normalization, I give you a table that is not normalized, similar to the examples that you see in the slide, and then I ask you to find dependencies, normalize the tables, and so on. Multiple choice true false questions include everything. So it includes all the topics that we covered before SQL. So do you have any questions? No? Oh, I have. So the exam is 60 minutes. But if I feel like you need more time, I may give you more time. Okay. So I set it 60 minutes because our class is just 1 hour, like around 15-20 minutes. And so I just wanted to make sure that we start the exam on time, and if there is a class after our class, we don't keep them waited. But I will, time is not an issue if you have time. If we start, for example, 10, and if I see that you need time, I will give you like extend it for like another 5 or 10 minutes. And yeah, let's go to the DDL. So just a quick review. We differentiated between DDL and DML commands, right? So DDL is about all the commands that are working on the structure of your tables, whereas DML commands or data manipulation language are about the manipulating the data, right? For example, if you update the value in your tables, if you, for example, insert data into your tables and so on. So here are example DDL commands: create, alter, drop. With create tables. And when you create your tables, it's just actually an empty table. And I will show you. So it will only have some columns, right? Like a student ID, name, and so on. But we have not have any data yet, right? So this is just an empty table. And then with DML, we know that insert is a DML command, right? We can insert data into our tables. We can alter table, which means we want to change the structure of the table. For example, you can use the alter command to change, for example, the data type of a column, right? Or add a new column, something like that. And drop table, just completely drop the whole structure, including the primary keys, indexes, everything, right? So it remains nothing. And we talked about data types. So the most frequent ones that we use are int, numeric, maybe text type, car, or char, varchar, and so these are the most, maybe float. And okay. So the important point about creating tables. So the syntax is easy, right? You just write create table followed by the name of the table and the column of the table, and then all the data types and so on. You have to remember to identify primary key if a table has foreign key. So these all have to be defined as when you are actually creating your tables, right? Now, the important thing is when you are okay. Thank you for mentioning that. It's good that you're still in the review mode. Okay, so the important point when you are actually creating your, please, when you are creating your tables is, yes, okay, good. So, so the important point was this, the question you had. So, okay, and the order of creating tables, right? So, for example, if you have, let's say, 4 tables, in your slide you had, for example, customer, product, order, and order line, right? So which table we created first? We have customer, product, order, order line. Which table will you create first? Hello. Customer, why? Yes, it's good. Okay, so we start from any table that doesn't have any foreign key, right? So, for example, if customer or product table do not have a foreign key, which is the case here, you can start from any of them, right? Doesn't matter if you start from product or customer, any of them. And then you go to order and order line. Does it matter if I create order first or order line? Or as long as I create them after customer and product is fine? Yes? Yeah. So as you see in the order table, right, we only have one foreign key, which is customer ID referencing the customer table. So when you want to create the order table, as long as you have created the customer table, you're fine, right? You can create, for example, this could be another order, customer and then order, right? Because it doesn't even refer to the product, right? And then you have this order line table, right? So order line table references orders and products. So before you create the order line, you should make sure that you have created the order table and also product table, right? can I create, could I have this order, for example, create order, then product, order line, customer. So if I start with order, and then product, and then order line, and then customer. Is this the correct order? Yes. Yeah, because we have to create customer before order, right? The order table references customer. So the correct orders are, for example, if you create customer, right? Product, order, order line. Now, this is one correct way because customer doesn't have any foreign key, so you can create it anytime. Product doesn't have any foreign key, so no problem here. And then order has one foreign key referencing the customer, but because we created customer, we're fine, right? And then order line, we need to be like created the product and order table first, which we already created, so we are fine here. Another correct answer is, for example, you create product, customer, right? Order, order line. Doesn't matter if you create product first or customer first. And then what else? You can also have customer, order, right? Product, order line. This is another correct way to create online. Order to create your order, to create your tables, because customer doesn't have any foreign key, so we're fine. Now the order table has a foreign key, but the foreign key referencing the customer table, which we already created, so we can create it next. Next, we can create product table, doesn't have any foreign key, so we have no issue. Order line, we need to make sure that we have created the order and product before, which we already created, so we can create these two. So there are these three orders to create these four tables, and all of them are correct. And in terms of syntax, we practiced this in hands-on today, so I'm skipping this. And then inserting data into table. Why did I put insert here in the DDL slide? Is it a DDL command? So when I ask you, is it a DDL command, you just have to ask yourself, does it have to do anything with the structure of the table? So when you insert your data into the table, are you changing anything in the structure of the table? No. The columns are the same, right? The table is there, you didn't delete it. And so it's a DML command, data manipulation language. You're inserting data into the table. The reason I put it here, just simple. I just wanted to for you to create like a real table with sample data in it, so that we can practice in class. That's the only reason. But this is a DML command. So what is the syntax? Insert into table name, and then you have two options. Like the option in the slide that you see, you specify the column name, values, and then you enter values in the same order as the column. The simplified version is that you can skip the column and then just insert the values in the same order. And you can also insert data, like let's say 10 rows at once using just one insert statement, and I'm going to show that too. You just write, for example, insert into product, right? And then after you finish like these values, you repeat the upcoming rows in the same structure. And insert is also subject to integrity control. What does it mean? Same thing with creating tables, right? When I say it's subject to integrity control, it means it matters how you insert data into your tables. So, for example, you should enter product and customer first, then order and order line, right? Because those links between tables, when you're also inserting data into your tables, they are still there, right? You cannot insert data into the, let's say, order table before creating before inserting data into the customer, because we have some data here referencing there. And alter table structure, you just write alter table followed by the table name, and then adding, and then here you have several options. So with the alter command, you can do several things. For example, here, you just add this new column, product type, and you have to define the data type of the column, right? And the second one, what does it do? We are altering table product. What are we doing here? Are we adding a new column? Yes. Yes. Yeah. Did you raise your hand? Okay. So any volunteers? Yes. The second one, alter table product, alter column product description. So what does it do? Yeah. Yeah. So we are just changing the data type. Okay. Um, and then alter table orders, drop column discount. So if you want to delete a column from a table, right, it means that you are changing the structure of the table. So you have to use a DDL command for which you can use alter, right? You cannot just write drop column discount, right? So from where you are altering table order, in the order table, you want to drop this column. And then we can also add some constraints into our tables. Like, for example, if you have a person table and you do not want to have any person under 18 years old, then if, let's say, you have an age column, you can have a constraint on that column. How do you do that? Again, using the alter table, right? Alter table person, add constraint. This is the name of your constraint, can be anything. And then you put your constraint with check. Do we have other types of constraints? Yes. For example, we can have foreign. Okay. So, for example, check that age is, for example, greater than 18. So you can. This one is an example of, again, altering table product, adding another constraint, which is a foreign key in this case. So again, add constraint followed by your constraint name, and then here you specify the type of constraint. So in this case, we want to add a foreign key, or maybe you want to add a unique index, right? So you can use, for example, unique here. You can use a foreign key or anything else. And then deleting a table from database. Do you use delete command? No. In SQL, we use drop command. Okay. So when you drop a table, it means that you are removing the whole structure. And do you have, like, does it empty your table? So when I drop table, let's say drop table a student, like this. Okay. So we have some data here. Let's say this is my table a student. If I drop table student, what happens? Someone else? Yes. Yeah, delete the whole table, all the data, all the keys, indexes, everything. So it is not like just truncating your table or emptying your table, right? You're just removing everything. Again, drop command also subject to integrity control, which means it matters in which order you are dropping your tables, right? Back to this example, order, customer, product, order line. If you want to remove tables. Let's say I want to remove all my tables, okay? So in what order can I remove them? Can I remove customer first? Always ask yourself, if you are removing a table, or if you want to drop a table, before you drop it, ask yourself, is there any other table in my database that is referencing this table? Or is there any other table that has a foreign key pointing to this table? So if I want to drop customer, do we have any table here, any other table that is referencing the customer table? Yes, the order table, right? So I cannot drop customer before I drop order. So I decided, okay, let's go drop order. Now, again, you have to ask yourself, is there any other table in your database referencing the order table? Yes. Which table? Order line, right? So I have to remove order line first. Again, ask yourself, is there any other table in your database that referencing the order line table? Yes? Yeah, sure. Yeah, but there are several ways, right? The same way that you had several ways to create the tables, right? There was no one way because, for example, in this case, we had two tables without foreign key, which meant we have more than one way to, like one correct order to create them. Same for the drop. Now, in this case, we should like start now. Okay, so we cannot start with customer. We cannot start with order, right? Can we start with order line? Yes. Can we start with product? What question should we ask? Is there any other table referencing product? Yes, we have order line referencing product, right? So we start from order line. Now, when we were creating our tables, we had several ways to start with, right? So we could start from order table, we could start from customer table, or like these were all the correct ways, right? We had three correct ways, I guess. This, and this. Now, if I want to drop them, I say the first table should be order line. Could there be any other table that I can drop first? No, no way. So we already tested out, right? The order line table has the most number of foreign keys, referencing a lot of tables. So we start from order line. And then we do the same for other tables. So after order line, you say, okay, let's, for example, drop the order table. Now, can you drop the order table? You have to check if there is another table referencing the order, right? Do we have that? Not anymore because you deleted the order line, right? And then you continue the same way. And so these slides are about connecting to SQL Server. Now, either I provided a screenshot whether you're using Azure Data Studio or sorry, you're using, for example, I think SSMS. I also provided yes, you also have the SSMS a screenshot. So if you're using Azure Data Studio, here is how you connect to your SQL Server. And we had a demo of that last session, right? How many of you could actually set up SQL Server? Okay, good. So I assume that you all, so how many of you are using the cloud service, like the Azure SQL, okay? How many of you are using other databases, like for example, MySQL, SQLite? No one? Okay. And do we have anyone still struggling with setting up their Azure account or creating database? No? No one? Yes? With SSMS? Hmm. After you install, you want to see your. So if you have set up, for example, let's say, regardless you're doing it locally or on the cloud or anything, we can do it also after class or in my office hours in more detail. But all of them have, and no matter what tool you're using on the client side to connect your server, like for example, Azure Data Studio or SSMS or for example, VS Code that I'm using now. All of them ask here for your server, right? Now, how do you find this server? The server name? I provided that in the installation guide. For example, in the case of setting up on the cloud, you could find your server name in the Azure portal, right? And then I'm going to show you again. And so here you just follow these and you have to make sure that this is true because you want to trust that. Sometimes you may get some errors here. That's because you have to, for example, add your IP address, which I also showed you how to do that. So I'm going to skip this because we are going to do hands-on today. So these are just screenshots of creating tables. So this is example with instructor student course, right? Yeah. So let's actually do this before go to SQL view, or I can finish the slide and then do hands-on. Yes. Mm-hmm. Mm-hmm. Always ask yourself, is there any other table referencing it? If there is, you cannot drop it, right? Because then mm, you have some table referencing nowhere, right? So you have to always start with tables that have foreign keys, right? And then finishing with the tables that have no foreign keys, right? Now you start from tables that have foreign keys, but maybe you have 10 tables in your database and 6 of them have foreign keys. Which one to start first? Then you have to check with the dependencies. Like most cases, if there is a table with more number of foreign keys, you have to deal with that first because it means that it is referencing more number of tables. And then if you already drop that, you open the way for other dropping other tables. After order line, so you drop order line. Let's say we want to drop order. We are fine. Now you say I drop order line and then I drop product. Okay, so you have to ask, the only table that referencing the product was order line, right? So you're fine. Yeah, yeah. So similar to the create table, as I mentioned before, there may be no there may be more than one correct order to create tables or drop tables, right? So SQL view, and don't worry, like the worst case, you get an error. It doesn't delete the tables for you if there is like these integrity issues, right? So you get error and then you have to realize, okay, what is the dependency? I have to first remove the ones with the foreign keys. So two options here is 1040. I think we finish a slide first and then do the hands-on, right? Agree? So I don't even mention the second option. Okay, SQL view. What is SQL view? I don't expect you to know that. So you can think of view as a window through which you are seeing your data, or you can think of it as, for example, let's say you have, it's not actually a real table, okay? So view is like a virtual table. And it's like, for example, let's say you are using a query, a complex query, very frequently, okay? So decide to, for example, store that query in like a view, and instead of like writing that query every time, rewriting it, which maybe takes a lot of time, right? So you just uh, work on the view instead of that complex query, right? You write the query once, store it in the view, and then you treat the view the same way as you do with the table, right? Is this clear? Okay. So for example, so here is the definition. SQL view is the result of stored query or set of queries to fetch data from the database. But why are we doing that? Because like for example, I had this issue myself. Like I had many, like a lot of large tables with many joins between them. So I ended up with like these complex queries, and then you are frequently maybe using those queries, not only once, and then every time it takes a long time. So it is more efficient if you store them in the view and then every time work on the view. And we see the example here. So here, for example, you have table 1 with these columns, table 2, table 3, and then for example, for the view, you can select, for example, which columns from which tables you want, because it's the result of a query, right? You may select, for example, column 1, 2 from table A, column 3 from table B, and so on, because you're joining those tables and storing the result in the view. And so it actually acts like a table, right? So as you see, we can, let me show you in the next slide. So when you want to define views in SQL, this is very similar to the table, right? So we were creating table name, right? Followed by the columns and their data type. Here, we create the view, right? Followed by the view name. For example, create view good student, right? We have in our database, we have, let's say, several tables, a student, instructor, and so on. And now we want to create a view with a student which only keep, it's a table, virtual table that only keep with the students that, for example, their grade is A or any condition that you have, right? So as you see from here, you're basically writing a query to find the students, right, whose grade are A or maybe even more, right? Here, just the condition is A. And so this is your query. You store the result of your query in this view, right? So that later you can only deal with this view containing all the information that you want, right? Not, for example, uh, more columns or more data than you need. And so I already mentioned this, but let's see if you listen to me. What is the difference between SQL views and tables? Because if you're creating, let's say, a student, a table view, right? For example, good student, right? What does it? It is like a table containing, for example, again, a student ID, etc., and the grade, but not all the students, right? Only students whose grade, let's say, is A, okay? Excluding the grade B, grade C, A plus, and so on. So what is the difference? What is the difference between table and SQL views? Yep. Yes. Anyone else want to? Okay. Yep. Could be because you are. Yeah. Okay, so as I mentioned before, so I already gave you the answer, right? You can think of a table, a view as a virtual table. So with a table, you have like physical, real storage. You're really creating a table in a database. With the view, it's not like that. It's not a real table there. It's just, you can think of it as a window, right? Through which you are seeing your data or the result of your queries, right? So that's the view. So we can think of it as just a virtual table. And do the views contain data of themselves? Can they have data from themselves? No, because it's basically the result of a query, right? So for example, in your query, let's say you get data from table 1 and join it with table 2, join it with table 3, right? But you only get some columns from each table, and then you have some conditions, like for example, grades greater than A, or a student, for example, in specific class. So you have some conditions, and then the result of that is in your view. And so what is the advantage? What is the advantage? Why do we do that? So I already can write queries to, for example, select students whose grade is A, right? Why do I need to create a view? Come on, I just started my explanation with the benefit of the view. Yes, please. I'm sorry. You mean you can reuse the same query more? Exactly, right? So as I mentioned, if you remember, I said sometimes queries are not as simple as we saw here in that slide. For example, select a student whose grade is A and the table has only 5 rows, right? Maybe you are dealing with tables with thousands or millions of rows. Maybe you are joining like really large tables, and this takes time. And if you are frequently using that query, you don't want to like waste time every time when you already created, for example, run that query once before, right? So that is an advantage, because then when you create the view, let's say if the view is the result of joining 3 big tables, right, which took an hour, and then you stored it in a view, and now you have that view, you can act like a table the next time, right? You can directly access that table instead of like joining those tables again. So this is, for example, one advantage. Do you know how you can query the views? For example, let's say you um, created a view to that is the result of several joins, and then you just simply select whatever you want. Let's say select a star from your view. This is your view name, right? Okay. Just I have a confession. I read your reviews on the course evaluation, and I see that some of you said I didn't read all of that yet, so that's my task in reading week. And then after reading week, I'm going to reflect on that. I will explain what I can improve this term and what is not feasible within this term. One of the suggestion was uh, using an alternative to the blackboard, because on the blackboard you may not really see, or it is not very well structured. Um, so maybe I can use this one. I have to just I forget. So I got used to the blackboard. I have to remember that. So that is something I can do, or write it at least better. And so apologies for my handwriting. So select the start from view name. Easy, right? Instead of writing a complex view, and it takes much less time. And index definition. So index is another important topic. Uh, so index is like a lookup table. Okay. So the main point of using index is to provide rapid access to data and for quick lookups. And I'm going to explain all of this with examples. Uh, so it consumes extra storage space and maintenance time. So this is kind of a disadvantage of an index. So if you have like a table with several indexes, all like these indexes takes space and also time. And let's say, for example, you have a book, right? You can think of index. Do you know the index in a book, right? So you can think of it the same way in the database. So the index in the database in your tables work the same way. So instead of reading through every page, you directly go to that specific page that you're searching, for example, a specific topic. It's the same here. Instead of reading every row in your table, you go directly into the row that you're looking for. And how a skill index speed up search. So as I said, it works like a book index. The index is sorted This is important because this will help you understand the next slide when I'm explaining how index is helping speed up the search. So when the index is sorted, because it is sorted, it helps the efficient search. So without index, if you don't have index on a column, it's unsorted, okay? Now, instead of scanning the entire table, it searches the index to find the matching values and then follows the pointers to fetch only the needed rows. So, for example, let's say you have this table with company ID, units, and unit cost, right? And this table is an example of unindexed table, right? And let's say we want to search for example, company ID 18, okay? So as you see, company ID 18 is in this row, this row, this row, this row, right? So you have several rows. But if the table is unindexed, how can you find all the company IDs that are equal to 18 in this table? How do you search that? Yes. Okay, what I mean is from the back end, how does it search to get those filters even? How does it reach to those when there is no index? Yes, one by one, right? It is very inefficient. It literally search every single row to find company ID 18. So it scans actually every single row, and then we call it a full scan table. So I wrote it here, the query search through every row to find the rows matching the conditions. And the condition here was that company ID is, let's say, 18. Now, let's say we have an index and we want to see how does that help. Now, when you have this index, so when you, for example, want to search for company ID 18, your system first search the index table. So you have like this index table. It first search here, which is sorted, right? So as you see here, you may not see here very well, but maybe in your slide. Now here, these are sorted. So when it's sorted, it contains also pointers to that specific rows in your main table. And instead of scanning every row in the table, now it use like these pointers from the index table, right? Use these pointers to directly access the data that you're looking for. And is it clear? How does it speed up the search? Yes? Okay. And then why is it important that it's sorted? Yep. Yep. Yes. Yes, but why? Yes. Because like many of like these algorithms, like for example, um, the binary search or other algorithms that work here, work on the sorted data. So if you don't have, if for example don't have any index and it is not sorted, you cannot it cannot even use those algorithms to efficiently search for what you're looking for, right? And so this was a question that was mainly uh, uh, students asked in my previous class, and this class is so silent. No one have any questions. So, in this case, yeah, the index reducing the number of search from what to what, searching how many rows to how many rows. So before it was, I think this is 10 to let's say about 20, right? it had to scan about 20 rows, but in real world, it could be much more, right? Thousands of rows. So instead of searching for thousands of rows, it can just go directly into like these, searching these 4 or 5 rows. Now, how do we create index? This is the syntax, create index, and then the name of your index. So this could be anything, okay? This means description here. So this is just the name that you choose. On, you have to specify you are creating index on which table, right? And here there should be a space, create space index, okay? On products, product description, which means I want to create a table, I want to create an index on product description column in the product table. Do you know which columns we choose index on? And when do we choose index? For example, if you have a table with several columns, so far I explained what index is, right? And I also explained why do we use index, because we want to speed up search, right? Now think about it. You have a table. When do you use it? On which column do you use it? Yes. Primary key is always index, exactly. And do you know any other columns that you may want to use index? Because primary keys by default are index. But you may want to also define index on other columns. For example, here on product description, which doesn't really make sense, but why the number of hands raising goes up and down? Okay, yes. On foreign keys, why? Mm-hmm. Yeah. Uh, Product description is not integer. Product code could not be integer. Anyone from the back of the class? Okay. Are you watching movies there? No? Yes? Yes? The column we are not updating very often. Why do we use index? Let's back to that part again. We use index because they speed up search, right? But we use those searches in the queries, right? So it is actually speed up also the queries, right? So you, yes, sorry, there, you, mhm. Multiple queries, you mean? So yes, if you want to, for example, let's say you have a column you are frequently using, for example, in joins, or that's why I was thinking about your foreign keys, because that's also what we use frequently, because you want to speed up the search and the queries, right? So if you're frequently using that column, so that could help in speeding up the search. So here is creating unique index, and the same, you just define unique index on, for example, product code. And why my slider like this? So here is create unique index as SXP and supply. And I think there are some issues with the. Okay, let me. I don't know how this happened. Okay, so should be good now. Okay. Oh, you don't see. Okay, so now it's better. Okay, now you see it. So create index, for example, this on product description, create unique index. This is another create unique index. And then this is how you drop index. Now, when to use an index? If the table is large, like thousands of rows or more, right? Because if your table is small, does it make sense to like consume extra space for the index and maintenance time for the index? No, doesn't make sense. If your table has only 100 rows or 50 rows, if the table is small, doesn't make sense because the search is fast, right? But if the table has like thousands of rows, millions of rows, and is large, which means the search will take time if it is not indexed, right? Then you may want to use index. If a column frequently appears in where, join, order by, group by, basically in queries, right? Where you want to, for example, let's say join tables, and the tables are large, takes a lot of time. So you want to speed up the query, right? So that is another way. Avoid indexing if your table is small, you have few distinct values. Then again, the search is easy, right? Or for example, is frequently updated and not frequently used in queries, right? So if it is used frequently in queries, as I mentioned before, you may want to introduce index on those columns. Now, what is the difference between primary key and unique index? And just to mention, primary key implies a unique index. So all primary keys are by default indexed, and because they are unique, so they are unique index. But I want to see what is the difference. Think about characteristics of primary keys. What are the characteristics of primary keys? Unique, right? Do they accept null? No. How about index? Can accept null, right? That is one difference. And can we have more than one primary key in a table? No, only one primary key. Can we have more than one unique index? Yes. You can define unique index on any column that you like, right? If that column is frequently used in your queries, in joins, group by, or things that takes more time, right? And table is large, you may, for example, let's say your table has 50 columns, you may want to define unique index on 5 columns. So this is another difference. And here you can see more like information about differences between index, primary, unique, full text, and so on. This is in MySQL, but almost the same here. And about primary key or unique index here. So I just summarized it here for you. So for example, with the primary key, the purpose is uniquely identifying each row, right? For example, a student ID uniquely identify each student in the student table. With the index, the goal is different, right? What is the goal of index? Do we want to uniquely identify each row? No, right? The goal is speeding up the queries. And that's why with the primary key, we cannot have null, right? If we want to have a column that can uniquely identify each row, it cannot be null, right? So primary key cannot be null, but here it could be. With the unique index, the same. Now, does it enforce uniqueness? If it is just an index, no, it could even not be unique, right? But if it is a unique index, then it is unique, right? So mostly confusion comes between primary key and unique index, right? And the difference is that because both are unique, but the difference is in their purpose, and also, for example, in accepting nulls or not, and in terms of whether index or unique index you can accept null. And one per table, only primary key, right? Index and unique index could be multiple columns. Now, very important topic which you have in your assignment and you will also have in your exam. And then I think we will have hands-on next session. So, integrity control. So, integrity refers to the accuracy or validity of data. What does that mean? It means you have to check for three things when we ask for integrity controls. The key restriction, it means that, for example, your primary key, you have to check each entity, each table has a primary key, and primary keys do not accept null. You have to make sure that it is not null and must be unique, right? So it's all about your primary key. And then you have some domain restrictions. So as the name suggests, domain restrictions means you have to check the format of your data. The format should be consistent, right? The range and so on. So it's all about the format and domain. And the most important one is cross-reference restrictions or referential integrity. It's about foreign keys. It's what we actually had when we were creating tables, right? When we wanted to make sure, for example, if this table referencing that table, we want to create, for example, this one first, right? Or when you want to drop tables, you start from the tables that have foreign keys and then go to the other ones. So let's see. And then we want to see what happens, for example, with those tables with foreign keys. Because what does it mean? If a table has a foreign key, it means it is linked to another table, right? And what does that mean? It means if you have, let's say, instructor ID or supervisor ID in the student table that is a foreign key referencing to the instructor table, it means you have a common column or common field in both tables, right? So you have instructor ID in both the student table and instructor table. Now, what issues may arise that you have to address with integrity control? What if you update, for example, instructor ID, right? What if you do any changes there? You want to see if it affects how it is reflected in the other table. Do you want to reflect the same thing? Do you want to, for example, put something as default and only apply the change in the parent table and so on? So let's see how we can do that. So within entity integrity, which I mentioned, is about your primary key. So you want to make sure no part of primary key is null, is unique, and so on. Referential integrity valid foreign key. So let's go to the example. And these are some definitions. I'm skipping these because it might be a bit confusing before you see an example, but after we see the examples, when you go back to this slide and read them, then it makes total sense. So insertion integrity, update integrity, and deletion integrity. So this is what exactly I mentioned now. So if you have a common field in two tables, right, means you have a foreign key, which was the primary key in another table, and you want to update that, right? Or you want to insert a new data into that, or if you want to delete that, you want to see what happens in the same field in the other table, right? So this is about like insertion, update, and deletion integrity. So for the insertion integrity, no row can be added into dependent table or a child table unless the foreign key matches the primary key in parent table or the foreign key is null. Update integrity specifies what action happens to rows in table if those rows have a referential relationship and the reference row is updated from the parent table, which is basically what I mentioned, right? If you update, for example, instructor in one table, what happens to the other one? Deletion integrity specifies what action happens to rows in the table if those rows have a referential relationship and the reference row is deleted from the parent table. For example, you are removing a department from department table, what happens to the department ID in the employee table, right? You want to see that. Let's say I'm working in ECS department and we are removing ECS from the department table. What happens? Then you have to think what makes sense. So maybe the thing that most that makes sense the most in this specific example, if you are removing a department completely from your database, right? It doesn't make sense. You have an employee working in that department, right? So if I'm removing ECS, I cannot have an employee Mona working in ECS. So I want to cascade or reflect that there. And that means that those define the different options that we have here. So on delete and update, we can have restrict, we can have cascade, we can have set null, and we can have default. So these are the options that we have. So if we have, let's say, cascade, means it just cascade whatever changes that we did to the other table. So we have restrict or set null. So I think in SQL Server is set null. I'm not sure. Should be either restrict or set null. And then we have cascade. No, sorry, no action, not set null. No action, restrict or no action. Sorry, restrict or no action, cascade, and then set null and set default. So what do they mean? So these are everything you need to set for the integrity control, and that's it. So restrict means, for referential integrity, right? When you have a foreign key. So restrict means I don't want to allow this change to happen. So for example, let's say I define an update restrict. It means you cannot remove or delete a department from a department table if we have an employee working in that department, right? So I'm not going to allow to remove the ECS department because we have employee Mona working in ECS department. Or I'm not allowed to remove a course if there are students enrolled in that course. You cannot remove ECS 3421 if there are students removing. Why do you do that? Because later, if by mistake you're removing something, right? Let's say you want to just removing a course, and then you want to have this note that, oh no, don't remove it. You have students enrolled in that course, or you have, for example, employees working in that department. So you cannot remove that course, you cannot remove that department. So that's one option, that is restrict or not, no action. Now cascade means if you are deleting that department, right, from the department table, if you remove the ECS department, you want to cascade that in the other table as well. So if, for example, ECS department is removed, it means that that role, that is Mona, working in ECS department, should be removed as well. And then we have set null and set default. Other options. Let's say you want to remove the ECS department, right? But you don't want to remove my data, right? And you also want to allow the ECS to be removed from the department. What is the other option? You can remove ECS from the from the department table, right? And then in the employee table, let's say this is your employee table, right? And this is, for example, employee ID, name, department ID, right? Let's say this is Mona working in ECS and so on. So another option is that when in your department table, so this is your foreign key, right? Referencing this table, department ID, ECS. So another option, I'm explaining the third option. So it says you can remove ECS, right? So if you remove the ECS department from the department table, you can set null here. So you put null here, right? So in this case, you allowed this department to be removed from the department, and you also kept the information for this employee. Another is set default. So for example, you have a default value for some field. Here doesn't make sense, but let's say okay, whatever it is removed here, I want a default value here. I don't know, whatever, like IT, business, anything. So then this value of the department should be this mic is really confusing. So this value should be updated to the default value that I defined here. The same thing for the delete, right? Delete and update, both the same. So if restrict or no action says if the specific row is referenced, changing or deleting is not allowed, right? So if this is referenced, because this is a primary key and you have a foreign key here and it's referenced here, you cannot delete it. This is the meaning of that. Cascade means you forward the delete, update, anything that happens here to the parent table or referencing table, and then set null or set default. As I mentioned, you just set it either to null or a default value. Now let's see it with an example. So this is the example I mentioned, right? Where do you have to define it? When you are creating your tables, right? So for example, you are creating table employee. You define the employee ID, employee name, so all the columns. You have to define primary key and foreign keys. Now today, we learned that you also have to check for integrity controls when you're creating your tables, right? What do you do? For example, wherever you have foreign keys, if you have a foreign key in a table, you have to define what happens on delete and on update. So what does it mean here? I defined on delete cascade. What does it mean? Yes? From both tables will be deleted. Exactly. So on update set null, what does it mean? Means that if you update the department, for example, ID in the department table, you don't update it in the employee table to the same value. Instead, you set it to null. So you put the null value there. So the same here on delete restrict. So here you cannot remove, for example, a department if there are employees working in that department. Now, can we remove department ID 3? Why can it be deleted? Not referenced in the employee table, right? So in this case, this one can be deleted. These two cannot be deleted because we have employees working in that department. Next example, on delete cascade. Again, here. So if any row from the department table is deleted, right, the related record or the related row in the employee table will be deleted as well, right? Because this is cascade. So if we delete it from here, we want to see that delete happening here. So we remove department 1. So department 1 is deleted, and so all the information about these Becky and Rob, right? But in reality, we don't want that. On delete set null, instead of removing Becky and Rob, we keep them. Instead, we set null here. On update cascade, the same thing. If you update, for example, department ID 1 to 8, you have to update it also in the employee table. And that's it. Do you have any questions?